Another example, what is the sum of a geometric sequence? We saw this in calculus. They told us, hey, memorize this formula and use it. Now you're going to see the reason behind this formula. So sum of a geometric sequence. Remember that we took the elements of a sequence and defined a series. In this case, for any real number except one number like r, which is not equal to 1, and any integer like n, which is larger than equal to 0, we have the following nice formula. This formula says, hey, if you take 1, add r to it, add r squared to it, and the rest of the terms, and you're interested in adding these terms together. Or in another format, another notation, if you take the sum of r to power I, r raised to power I start from 0 and stop at n, this sum is equal to, well, r to power n plus 1 minus 1 divided by r minus 1. Okay, this is a formula that you saw in calculus. You used it a lot. Now we're going to see the proof. Why left-hand side is equal to the right-hand side by the method of induction. Let us prove it. By induction. So remember that the very first step in induction is the basis step. In the basis step, we're going to take the very first element in the domain. Well, what is that? Are we working with R or are we working with N? Guys, it depends on N. So we show that P of 0 is correct. We show that P of 0 is true. It's correct. So N is equal to 0 and Pn or Pk in this case says that, well, 1 plus R plus R to power K equals to R to K plus 1 minus 1 divided by R minus 1. Or you might say that, hey, K is equal to 0. K is any number less than equals to N. Okay, let's check it. This is true. If I plug in K equal to 0 or N equal to 0, the very first element, the very first R to power 0 is equal to 1. So on the left-hand side, my left-hand side is 1. What is my right-hand side? My right-hand side is just a fraction, this fraction here. So if I plug in 0 for K, R to power 1 minus 1 divided by R minus 1, just you can simplify these two terms. R minus 1 divided by R minus 1, which is 1. So as you can see, left-hand side is equal to right-hand side. So what's the meaning of that? It means that the basis step is true. It means that you're allowed to go to the next step. The next step is called inductive step. In the inductive step, we assume that P, K, this formula is true. We try to prove Pk plus 1, assuming that Pk is true. Okay, So what is pk plus 1? pk plus 1 says, hey, if I change this to k plus 1, left-hand side is equal to, guys, everywhere that you see k, you're going to replace that by k plus 1. Left-hand side and right-hand side are equal to each other. So it says, hey, 1 plus r plus r2k plus r2k plus 1 is equal to, so let's put a question mark on top of it, equals to r to power k plus 1. It already has another one. Don't forget to put that here. Minus 1 divided by r minus 1. So again, you can use either substitution or do the subtraction. Both are fine. Since we know that 1 plus r to the k has a formula, you can write it in closed form, which is r to k plus 1 minus 1 divided by r minus 1. You're going to replace, you're going to substitute this here. Very good. So this guy becomes r to power k plus 1 minus 1 divided by r minus 1 plus, we're going to add the rest of the terms, r to power k plus 1. Okay, now take the common denominator and show that this addition is equal to this guy here. Common denominator. So you have r to power k plus 1 minus 1 divided by r minus 1 plus r minus 1 times r to power k plus 1. Okay, distribute this guy into parentheses. You're going to get r to power k plus 1 minus 1 plus r to power k plus 1. This guy has invisible power 1, so you end up with k plus 2 minus r to power k plus 1 divided by r minus 1. As you can see, you can cancel out the opposite terms. You're left with r to power k plus 2 minus 1 divided by r minus 1. And obviously, these two fractions are equal to each other. This is what you try to prove. These two are equal to each other. So what is our conclusion? The conclusion is, by the method of induction, we were able to prove this formula. I got new markers. By the method of induction, we just prove that if you take these terms, add them together, r is not 1 and is larger than equal to 0. 1 plus r squared plus r to the n is equal to r to power n plus 1 minus 1 divided by r minus 1. So if on the exam I ask you to prove the sum of the geometric sequence, you need to know the formula. You need to memorize this guy or write it on your note and have this formula ready. This is the sum, r is not 1 and n is larger than equal to 0. This is the sum of geometric sequence.